Hello, friends. Myself, Dr. Nandakumar Raubawale from College of Engineering, Ambazogai, is going to deal with numerical methods in mechanical engineering. In previous lecture, we have discussed about significant figure, importance of significant figure, and the definition of accuracy and precision, and the difference between accuracy and precision. Today we are going to discuss the error. So generally the errors which are discussed are approximate error and true error. So today we are going to discuss about error. So here we will discuss two kinds of errors. One is approximate error. Approximate error and true error. Now, in case of this numerical error which arises from the use of approximations to represent exact mathematical operations and quantities, generally what we do, we represent the expressions by using mathematical operations, and certain quantities we approximate instead of giving the exact values or exact quantities, and that introduces the error. These errors include truncation error, which results when the approximations are used to represent exact mathematical procedures, and round-off errors, which result when approximate numbers are used to represent exact numbers. So for example, yesterday we have seen pi is equal to 22 by 7, 22 divided by 7, and if we take this exact value of pi, that is going to be 3.142857 857,142 8571 and so on. So this is the exact or true value of any parameter, that is the value of pi. But what we do, instead of writing this digit, this number, we take approximate number as 3.142, and rest of the significant figures we eliminate, and that is the reason why the errors are introduced. So now the errors are introduced because sometimes we represent mathematical relations or mathematical procedures exactly, and sometimes we take a round of values, and that results into the error. Now the difference between the approximate error and true error that we have to study. The relation between the true value and approximate value is nothing but the error. So the error is defined as the relation between or difference of a true value and approximate value. That is nothing but true value is equal to approximation or approximate value approximation plus error, or this error can be given as true value minus approximation. where this error is represented by E suffix t. So this E suffix t is nothing but, we call it as a true error. This is true error. The demerit of this definition is that it does not consider order of magnitude of the value under estimation. Demerit of this definition is that it does not consider the magnitude of the value under examination. What does it mean? Say for example, you are going to measure a distance from Ambejogai to Latur. The exact distance between these two cities is, say for example, 50 km. And by mistake, the person who is going to measure, he measures it as 51 km. So here error is, or 50 point, instead of 51 he measures it 50.002 km. Error is 0.002 km. Now another person measures distance between bus stand of Ambejogai to College of Engineering. Say actual distance is 2 km, but by mistake the person measuring measures it as 2.002 km. Here also error is 0.002 km. So looking at these errors, error 1 is same as the error 2, but practically speaking the error 1 is very small compared to error 2, because this error 0.002 km is for only 2 km, and this 0.002 km is the error for the distance of 50 km. Therefore this error which is measured in first case is very small compared to the error in second case. Approximately the error in second case is 25 times the error in first case. So now if we find out this error in percentage, say here percentage error is 0.002 divided by 50 kilometers true value, and here it is 0.002 divided by true value is 2 km, 2.00 km. So into 100. So now if we calculate this in first case, 0.002 divided by 50 gives us percentage error as 0.004%, and in second case 0.002 divided by 2 km. So this is 0.1%. So So in first case error is 0.004%, whereas in second case error is 0.1%. So that is nothing but simply the error which is measured is the difference between the true value and approximate value. This does not consider the magnitude of the value which we are going to measure, true value of the quantity or parameter. So that's why we have to go for relative error. So relative error is defined as the ratio of the ratio of error to the true value into 100. So this gives is in percentage. That is nothing but in first case if we measure error in simply error, so in both the cases, in first case and second case, error was 0.002 kilometer. But when we obtained the relative error, so at that time we have realized the error in the measurement of first case is very less compared to the error of measurement in the second case. So this error is very high and this error is very small. And if we study only simply error, so in both the cases error is 0.002. So to have the clarification or to have the clear idea about the error, so here simply error is not considered, a relative error is measured. So therefore the relative error gives the real sense of the error existing in the measurements or in the system. In case of numerical method, the true value will be known, but generally in practical cases the true value of the term may not be known. So when the true value is known, then the error can be obtained and that error is known as the true error. Say for example, so error which we call as a true error is equal to true value minus approximate value or approximation, or if we want to have a relative error, divided by true value. Into 100. So this is called as a true error. In majority cases, when we study with the help of mathematical model, then we may be knowing the true value. But in majority of practical cases, the true value is not known. So only approximate values are known. And from that approximate values, we have to obtain or we have to reduce the intensity of errors. So now, in a real world problem, we will not know the true value of entity. For these situations, an alternative is to normalize the error. So how to normalize the error is the question. So now normalization means normalize the error, in which case we have to normalize the error. So when we don't know true value, we know first approximate value or first approximation, approximation 1. Then from this approximation 1 we obtain another approximation, that is approximation 2. So this is approximation 1 is first value which we obtained by numerical method. Approximation 2 is the second value which we obtained. So this second value or second approximation is improved version or improved result. and compared to first approximation, the error in second approximation is less, and we find out the approximate error, and that approximate error is nothing but the difference between first approximation approximation 1 minus approximation 2, and if you want to find out relative error, then divided by approximation 1 into 100. So the place of true value, in place of true value, first approximation is placed here in the numerator as well as in the denominator. So this gives us approximate error. So here in this numerical methods, we use the iterative methods, or iterative approach is used to compute the new answer. So in numerical method, iterative method is used. Iterative method is used, and this iterative method gives results, and these results are improved by making iterations. So these iterations refine the results gradually, and the answers are tending towards the true value. Now in this case, this process is performed repeatedly or iteratively in order to successively compute better and better results or better and better answers. For such cases, the error is often estimated as a difference between previous and present approximation. As I told you, approximation 1 and approximation 2. Thus the relative error determined in case of approximate error, EA, is given as approximation 1 minus approximation 2, or present approximation minus previous approximation whole divided by present approximation. Into 100. So this is called as the approximate error. We have used two equations here. Say this is equation number 1, that gives us true relative error, and this is the another equation, equation number 2, which gives us approximate error. The sign of equation 1 and equation 5 may be either positive or negative, but here we are concerned with the absolute value of these errors, not concerned with the sign of the error, whether this error is positive or negative. Now we will see Maclaurin series, how this approximate error and true error is obtained for this Maclaurin series. So just we will have an example. With this example, we will have the clear idea about what is the true error and what is approximate error. So here we will have a Maclaurin series. So this Maclaurin series is given by, for value of ex, e to the power of x is given as 1 plus x plus x square divided by 2 factorial plus so on plus x to the power of n divided by n factorial. So now for x is equal to, we will simplify this, for x is equal to 0.5. If we take x as the value of this variable x as 0.5, then e to the power of 0.5, if you operate your calculator, this gives result as 1.64872 1271 and so on. This is true value of Maclaurin series with the variable value x is equal to 0.5. So e to the power of 0.5 results as 1.648721271. This we assume as a true value. Now we'll have a table to compare this. So in this table, what I will do is, first iterative method we will do ter. We take as a ter, then result, and true error, percentage true error, and approximate error in percentage, that is relative. So first we take one term. One term means, what is this one term? So this is a Maclaurin series. So first only one term means first one we will take and rest of the Maclaurin series we neglect. So only e to the power of x we consider as equal to 1, and all other terms we are going to neglect. We are going to approximate e to the power of x is equal to 1. So result of this e to the power of x, even if we substitute x is equal to 0.5 whatsoever, so e to the power of 0.5 gives us answer as 1. So result is 1. So what is true error? So if you find out true error means what is true value? True error is equal to true value minus approximate value divided by true value into 100. Now this error we find out. True value is 1.6487, we substitute here, and approximate value is now 1. So 1.648721271 minus 1 means it is 0.6487 divided by true value is 1.6487. So true value is substituted as 1.648721271 and approximate value is substituted as 1. So answer which we get is 39.3%. But we don't know the second estimate, only one estimate, that is approximation 1. We call this as AP1. Approximation 1 is known, that is approximation 1 is 1. So we don't know approximation 2, that's why we cannot find out first approximate error. Now we are going to keep two terms. Which are the two terms? E to the power of x is equal to, we will write as 1 plus of x. That is nothing but 1 plus of x value is 0.5. So answer is 1.5. 1.5. Result is 1.5. We can write here. So now we find out true error. Now true error is equal to, true value is 1.648721271 minus approximate value which we have obtained is 1.5. So here we substitute it as 1.5 divided by 1.5 into 100. So now this results into 9.02%. So approximate error is 9.02. Now true error is 9.02. Now approximate error we can find out. Approximate error EA is equal to first approximation and this is second approximation. So approximate error is nothing but present value or present approximation minus previous approximation. Previous approximation is 1 and present approximation is 1.5. So 1.5 minus 1 divided by 1.5 into 100 gives us 33.3%. So here approximate error is 33.3. So here to find out approximate error we are not going to consider true value. True value is not considered. Second approximation minus first approximation divided by second approximation gives us approximate value. Then we consider three terms in the sense e to the power of x plus e to the power of x is equal to 1 plus x square divided by 2 factorial. Now we substitute x is equal to 0.5 and then we get this as answer as 1 plus 0.5 plus x square is 0.5 square divided by 2 factorial means 2. So if we simplify, this will be 1.625. So this is a result will be 1.625. Now true value is 1.64 and this approximation by considering three terms we get 1.64. So here to find out true error 1.648721271 minus 1.625 divided by true value is again 1.648721271 into 100. So this gives us the true error as 1.44%. 1.44%. So this error is 1.44%. Now we want to find out approximate error. Approximate error. Now in this case approximate error. So previous value which we obtained was 1.5 and new value which we have obtained is 1.625. So approximate error can be obtained as present value is 1.625 minus previous value is 1.5 divided by 1.625 into 100. So here true value plays no role in approximate error. So here only the present value minus previous value divided by present value, this gives us approximate error as 7.69%. 7.69%. So now we consider four terms. At that time this results into four term means e to the power of x is equal to 1 plus x square divided by 2 factorial plus x to the power of 3 divided by 3 factorial. At that time by substituting x is equal to 0.5 we get this as 1.6458333 and so on, and then approximate error which works out to be true error works out to be 0.175, whereas approximate error works out to be 1.44%. 27 for approximate error. So this is previous value and this is present value. So previous value minus present value divided by present value gives us approximate error. So when we consider 5 terms, that is e to the power of x is equal to 1 plus x square divided by 2 factorial plus x to the power of 3 divided by 3 factorial plus x to the power of 4 divided by 4 factorial, then this result which we obtained as 1.648437500, and then approximate true error which we obtain is 1.0172 and approximate error becomes 0.158. To find out approximate error, then again this 1.645833 is previous value and present value is taken as 1.648437500, then we get approximate error. But to find out true error, always the true value is taken as this 1.648721271. So on, say if we consider 6 terms, then the result obtained is 1.648697917, and true error works out to be 0.00142, whereas approximate error becomes again 0.0158. So in this way this true error also gets reduced and approximate error also gets reduced. The rate of decrease in the true error is rapid and the rate in the reduction in the error, approximate error, is comparatively slow, gradual. So this is how we find out true error and approximate error. This is the difference. So in case of finding true error, we consider true value as a reference, and in case of approximate we are not going to consider true value as a reference. Only in case of approximate error, the present value minus previous value divided by present value is taken into account and the error is obtained. Now we will see what is a round-off error. Now we'll see what is a round-off error. Now the numbers such as pi, e, √7 can be expressed by fixed number of significant figures. So the value of pi, if we take pi value, it is 3.142857142857, whereas the value of e is 2.718281884 59, and the value of √7 is 2.645751 311 0646. So now sometimes we are going to omit some of the significant figures. So these numbers have got significant figures: 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 significant figures are there. So out of 13 significant figures, what we used to do, instead of this value of pi 3.142857, we take it as approximate value as 3.142. So rest of the significant figures are eliminated. That means the true value, and this value we are going to take it as a 3.142, which we call as approximate value. And because of this, rounding of error is introduced. So instead of 2.7182112, so we are going to take it as 2.72. So this is approximate. So this is true value, this is approximate value. Because of this attempt, we are going to eliminate the significant figures, and elimination of significant figures or omission of significant figures are going to introduce error, and the error introduced is known as the round off error. So here round off error is calculated in first case. Say for example, true value is 3.1428571 428571 minus approximate value is we are going to take it as 3.142. So divided by true value, again we take it as 3.1428571 428571 into 100. So this is nothing but the error. We call it as a round off error because this error is introduced due to omission of significant figures. So now next one is truncation error. So what is this truncation error? The truncation errors are those that result from using an approximation in place of an exact mathematical procedure. So truncation error is introduced because we are going to use approximations instead of using exact mathematical procedure. Just now I have told you e to the power of x is equal to 1 plus x square divided by 2 factorial plus x to the power of 3 divided by 3 factorial plus and so on plus x to the power of n divided by n factorial. So this is exact mathematical relation or procedure. Instead of using this, what we do, e to the power of x, we take it as 1 plus x square divided by 2 factorial plus x to the power of 3 divided by 3 factorial, and rest of the series is omitted. And this even by knowing the exact mathematical procedure, we are going to take some approximate mathematical relation, and because of this the error is introduced, and that is nothing but the truncation error. So here we'll have one example of falling parachute. So a parachute when falls from high altitude, the velocity with respect to time is going to change. So the graph is plotted, say for example. So on x-axis time is taken, on y-axis velocity is taken. So at time ti, initial time ti, velocity is say vi or v of ti. At time ti velocity is v, and at time ti plus 1, time t I plus 1, at the time t I plus 1, velocity is v of t I plus 1. So this is the point, say, point P and Q. But meanwhile, while passing this parachute from high altitude, it will not have a linear relation with respect to time to velocity. So it passes through a curve path. Now if we take slope of this curve considering initial and final point, so this P and Q, we can write this slope as dv by dt is equal to delta v, change in velocity, divided by change in time, that is nothing but v of t I plus 1 minus v of t I divided by t I plus 1 minus t I. So this is what we call as a approximate slope. This is approximate slope, which is with respect to P and Q. But actually the slope at point P, if we take, so actual slope is going to take this path. So this is approximate slope. And the true slope passes at point P in along this line, and that we represent as dv by dt. So this is the mathematically obtained slope, but practically or actually the slope is something different, and this error in between these two slopes, so this is slope 1 phi 1 and this is slope 2 phi 2. Actual or true slope is phi 2 and the approximate slope is phi 1. So difference between these two is nothing but the truncation error that introduces the truncation error. We call it as a truncation error. Instead of using exact mathematical correlation dv by dt, so we are going to use approximate correlation, and that introduces the truncation error. So this is what about the error, approximate error and true error, whereas round off error and truncation error, how these errors are introduced in these measurements or in this study or analysis that we have discussed. So tomorrow in next lecture we will discuss about Taylor's theorem and significance of Taylor's theorem. Okay, thank you.